and we'll look at solving trigonometric equations in quadratic form. So again, from the book, solving a quadratic equation may be more complicated, but once again, we can use algebra as we would for any quadratic equation. Look at the pattern of the equation. Is there more than one trigonometric function in the equation, or is there only one? Which trig function is squared? If there's only one function represented and one of the terms is squared, think about the standard form of the quadratic. Replace the trigonometric function with a variable such as x or u. Excuse me. If substitution makes the equation look like a quadratic equation, then we can use the same methods for solving quadratics to solve the trigonometric equations. So fortunately, this one again is just from 0 to 2 pi. So don't have to worry about the generator, as I call it. I'm going to say u equals cosine of theta, which turns this cosine squared theta plus 3 cosine theta minus 1 equals 0 into u squared plus 3u minus 1 equals 0. Now that one can't be factored. That's a prime one. So what we're going to do is look at the quadratic formula, and I'm going to say u equals negative 3, so negative b, plus or minus the square root of b squared, so 3 squared, minus 4 times a, which is 1, times c, which is negative 1, all over 2 times a, which is 1. So we have negative 3 plus or minus the square root of 9 plus 4 over 2. So u equals negative 3 plus or minus the square root of 13 all over 2. Okay, so we found u, and we have two different values, by the way. So what was u? It's cosine theta. So cosine theta is going to be negative 3 plus the square root of 13 all over 2. And cosine theta is negative 3 minus the square root of 13 all over 2. But maybe we should look and see what these values are, because a cosine of a theta can't produce more than 1. And let's see if that happens in either of these cases, or produce less than negative 1. So I have a suspicion that negative 3 minus the square root of 13 over 2 is going to be smaller than negative 1. So let me just get my calculator here. And I have negative 3 minus square root 13 all divided by 2. Yeah, that's going to be negative 3.30278. Let's call it that. And that's going to be less than negative 1. So that's not in our domain of negative 1 to 1, or our range. So not in the domain of the inverse function. So we don't have to worry about that one. So we're going to have to worry about the other one. Let's see. Maybe just check those values. Yeah, so this negative 3 plus the square root of 13, all over 2 is approximately 0.30278. So that'll work. So now that means we're in a first quadrant situation here. But it means, cosine's positive in the first and fourth quadrants. So we're also going to look for it to be the reference angle down below. So this is our 0.30278. So really that second angle is going to be 2 pi minus the 0.30278. That's what that one's going to be to get this other angle. So we'll look at cosine inverse of our negative 3 minus square root of 13 over 2. No, plus. And what's that going to be? So cosine inverse, I'm going to highlight this value. I'm going to do it on my calculator, not on the computer, because it's going to be easier for me to. Nope. Do this. And I just realized I probably shouldn't say this right here. Probably shouldn't say that. It's going to be whatever the angle is going to be. Minus So this is, I should say this is the output. That's not 0.03, 0.30. So this is our theta, and then theta prime. So these are going to be the same, but then I'm going to do 2 pi minus theta to get this other angle here. That other angle. Okay. Okay, so what I'm getting here is I get 1.263193. Let's call it that. So that's our theta. And then we do 2 pi minus theta is going to be dead air, 5.01999. So these are the two angles that would satisfy this equation. Okay, let's go on. Solve this equation exactly. Okay. So I'm going to say in this case, I have 2 sine squared theta minus 5 sine theta plus 3. So I'm going to say u equals sine theta. So it's 2u squared minus 5u plus 3 equals 0. And this one can be factored. So it's going to be 2u minus 3 times u minus 1. So 2u minus 3 equals 0, means 2u equals 3, or u equals 3 halves. So from this, we're looking where sine theta equals 3 halves, and, well, sine can't produce something bigger than 1, so there's no solution there. Then we have u minus 1 equals 0, so we went where u equals 1, so where sine theta equals 1, and from 0 to 2 pi, theta would just be pi over 2. That one was not so bad. Let's try this next one. We have 2 sine squared theta plus sine theta equals 0, again from 0 to 2 pi. So I'm going to factor out a sine, so sine theta, oh geez, okay, right what I'm thinking, times 2 sine theta plus 1, where is that going to be 0? So if it helps, we could have just said u equals sine theta. It had 2u squared plus u equals 0. So u times 2u plus 1 is 0. So where is u equal to 0? And where is 2u plus 1 equal to 0? So again, where is sine theta equal to 0? And from 0 to 2 pi, that's going to be theta equals 0, pi, and, oh, this says strictly less than 2 pi. So let me see if I can change that. Change that to this. There we go. So we'll go with those two. And then we have the case where we have 2 sine theta plus 1 equals 0. So that's what 2 sine theta equals -1, or sine theta equals -1/2. So that's going to occur where theta is, so it's a third and fourth quadrant, so it's going to be 7 pi over 6. I had this right the first time. 7 pi over 6 and 11 pi over 6. So those are our values. This video is getting long, but I think this is the last problem for this video. And we want to solve this exactly. Yay, that means we don't have to use a calculator. So we have, again, if I said u equals sine theta, we would have 2u squared minus 3u plus 1 equals 0. That means 2u minus 1 times u minus 1 equals 0. 2u minus 1 equals 0 means 2u equals 1, or u equals 1/2. So sine theta equals 1/2, when theta is going to be pi over 6 or 5 pi over 6. And then for u minus 1 equals 0, that's where u equals 1. So that's where sine theta is 1. So where theta is pi over 2. So our solutions are pi over 2, pi over 6, 5 pi over 6. Unless I wrote this wrong. Well, this is the correct answer to this problem. I'm looking at my reference problem, and it should have been a plus sine theta. No, I'm reading the wrong problem. Reading the wrong problem. Yep, this is it. Okay, and that's it for this video. Sorry it's so long.